Welcome back to my channel, and today we will together solve the daily LeetCode problem. So for our today problem, that is the hard problem and it is the greedy problem, so we don't have the way, the pattern to solve it effectively. However, I don't think that this problem is too difficult for you guys. However, we still need some kind of the observation to solve this problem. So let's go and solve it together. So here we have an example, and then our requirements is that we need to do the things like we need to find the nums array, as if each element, all of the elements in here is satisfied on one condition. It means that all of the numbers in here, it will appear at least, we have at least two number in each interval, given in the intervals. For example, in here we have the intervals 1 3, right? So it means that is 1 2 3, and then in each interval in here it includes all of the number from the start to the end, and all the things in here they are integer. So that is the first interval. The second interval is 1 2 3 4, right? In here they give us the start and the end of the interval. So here we have 2 3 4 and 5. Here we have 3 4 and 5 again. So how can we choose? So it means that somehow we can think about we can choose the number which the highest frequency or the intersection, right? Okay, so that is a good idea, so let's choose it. Firstly, we can see that 2 is the common number, so in here we choose the 2, and with the 2 it means that we have the number which appear in the first, the second, and the third intervals. And here we still can choose the 3. It means that we have a number which is appears in the first, second, and the third, and also the fourth interval. It means, however, in here after we choose numbers, two numbers, and then somehow the conditions for the first one, second one, and the third one has already satisfied. And the next one we only need to choose the 4, and then of course in here we can choose the 4 over the 5. It doesn't matter. Eventually we have 2 3 and 4, or 2 3 and 5, and with this we have the size of the nums, which is the 3. Okay, so in here we don't need to find the nums. However, we just need to count how many elements we have in the num. So that is our answer. Okay, so how can we solve this problem? Right? So yes, so with this problem, so we can see that that is a little bit tricky because in here they short it for us. So we can see that we can start from the first interval, which is 1 2 3, and 1 2 3 and 4. Let's say that we are examining two consecutive intervals, and then we are from the current one in here. So our question is that which number should we choose? Okay, let's say that which number should we choose, and then the answer is that we should choose the number which is at the end of the interval. So why? Because if we choose the numbers at the end of the interval, and then it gives us more chance to have the intersection not only with the next interval but also the interval in the future. And because we short our intervals, right? And then so it means that if we continue to consider other interval from left to the right, it means that if we choose the number at the end of the interval, the current interval, it is more likely to intersect with other intervals number, right? Okay, so let's say that in here we call this one is the end, and the last one I call that is the n1, and the last the second last one I will call that is the n2. So how can we operate this one? Okay, so we may convert this problem in another smaller problem. Okay, so we are at the current one, right? And we choose these two numbers, and then we consider the next one. Okay, so in here we have three cases. The first case is that in here, so it means that we just draw the x-axis, And let's say that what if the two interval has no intersection. Just assume that is not in our current interval, but yes, let's assume that. So this one is 1 2, this one is 3 4. Okay, so it means that like in here we have no intersection, right? And our task is what we need to maintain that like in the num it has the numbers which is at least appear 2 times in the interval. So it means that in here if the intersection is 0, it means there is no intersection. We need to put the 1 2, which is the e1 e2 in the nums eventually, right? And then here if we consider next, that is the 3 4, and then somehow like we need to expand this one as 1 2 3 4, right, to satisfy our conditions. Okay, so that is the first the first case. And then in this case we have what? So we can check in here is that like, yeah, in the first case, if the e1, let's say that in here like I will call that in the next sorry, e2, right? That is, what if the e2 smaller as in here this one, this call, let's call this one is the next, I mean the next interval. And then so in here if the e1, which is if what if it is smaller than the next 0, right? It means that there is no intersection. So it means that like we need to increment our count by 2. It means that we will add these two numbers into the count, right? Otherwise, okay, so for now we will consider the things like intersection. So when intersection happen, and then like we have two cases. The first one in here is that if the e2 is greater or equal to the next 0. So it means what? It means that like in here we can use both the e2 and e1 in the next interval, right? So it means that we don't need to do anything. So count in here, we just go to 0. We don't need to do anything. We count it, we increment it by 0. So here if the e2 is greater or equal than the next 0, right? So it means that we can use both of these number. Okay, so here is that like what if the e2 it is like smaller than the next 0, and the e1 it is like greater or equal the next 0. Yeah, so in here, so we can have this condition. So it means that it is expressed by this case. So for example, in here we can see that somehow like we have one overlapping region. So here like we will consider until here, that is the last row, and then like we can see that we have one overlapping number, which is the 3. And then so in here the trick in here is that like we will put this one as the e2. We will put this one as the e2, and then we will get this one as the e1, because like we hoping that the e2 still can do something in the future, right? And then we get the e1 as the for this value on the right, to have the element overlapping with the future values. Okay, yep. So let's do the code together. So for now we will initialize the count equal to 0, and then because like in here we need to short the intervals, so let's say that is the shorted of the intervals, and then the key will be equal to lambda of x, and then x of 1. So here like we will short the interval. So yeah, so print interval. Okay, let's check. Okay, so here we can see the intervals. Yeah, they have already shorted this one for us. Yeah, so we can check, and then so for now we will get the interval in enumerate through the intervals. And then so here because I use I in here, because like if the I equal to 0, and then somehow like we need to get the n2 n1, which is equal to the interval of the minus 1. Okay, so what is the value of n2? n2. Okay, so the value of n2 in here, that should be the n1 minus 1. Yeah, that is not the interval minus 2, right? Because the interval minus 2 is like the things like the start index, so don't be confused, right? Yeah, so that is the first one. And then so in here, like, of course we can do nothing, but we will increment the count by 2. So if that is not the 0, it means that initialize value. And then like we will check that like 3 conditions we have already established together. So in here, like if the n2, it means if it is greater than the interval 0, so it means that that is the current one. And then we can see that like we will do nothing, it means that we continue, for example. And then what else? Yeah, in here that should be the else if. Like, yeah, what if the n2 that is smaller than the interval 0, and the n1 it is like greater or equal than the interval 0. So in here, like we have exactly one overlapping number, right? So in here, like firstly we count by 1, and then like in here, like we assign the n2 equal to the n1. And then if, however, in here that is very tricky. What if the n1 and n2 is similar, right? What if they are similar? So it means that they point to the same thing, right? However, like in here we want to get 2 numbers, always remains 2 numbers. So that's why, like if the n1 equal to n2 and n2 will be equal, so in here, like we need to assign the n1, it is equal to interval of minus 1, right? And if n2 equal to the n1, and it should be the n1 minus 1. Okay, yeah, that is very tricky that in this step, and in this step it make me fail a test case as well. So yeah, so and then the last case, like if the n1 it is smaller than the interval 0, of course like you can use the else in here, but for me, like I would just want to explain for the code, so that's why I use a condition explicitly. Yeah, so in here, like we just need to get the n1, which is like equal to the interval of minus 1. We get the last one, right? And then we assign the n2 equal to the n1 minus 1. And in here, if that one, it means that in here, this means that there is no intersection, and then we count by 2. And then here, like we turn the count. Okay, right. Okay, so we can make it work from here. Let's submit and check the result. Yes, so I think it works, even though like sometimes it can beat 100% of own submitted codes. Yeah, I think that's all the things for our today. But from my perspective, this problem is not too difficult, but the challenge is that, like, yeah, that is very hard to handle the corner cases, because the corner cases is like this. I feel like when it makes me it makes me fail the test case. Yeah, right, thank you so much for watching my video, and if you like, and if you want to give me motivation to make more videos for you guys, please give me a like or comment or subscribe my channel. Yeah, again, thank you so much for watching my video, and see you next time.